So we have g of h of x. So g of x in this case is going to be square root of x minus 4. And h of x is equal to 2x plus 1. So what this is saying, or looked up there, this is between g of h of x. So the way that, again, I look at this, guys, if I said, what is g of negative 1? Well, let's do g of 5. If I said, what is g of 5, you're just going to plug the 5 in for the x, right? Whatever is inside of there, you just plug in for the x. So that'd simply be square root of 5 minus 4, right? And plug that in. Square root of 1 equals 1. So in this notation, we're basically taking h of x and we're plugging it in for x. So this example is going to look like this. H of x minus 4. So you're basically now replacing the x with a function rather than a number. It looks a little weird, but it's the same process, the same operation. And what's important about this is we now know what h of x is. H of x is 2x plus 1. So I can simplify this to 2x plus 1. And then fortunately for us, we can actually simplify this. So when you're doing domain and compositions of domain, you actually have to look at the domain twice. You have to look at the domain of the function that you're plugging in, and you have to look at the domain of actually what we call the composition of the two functions. So we don't need to worry right now about h of x, because what's happening with h of x? It's all real numbers, right? So we don't need to worry about that. But now once we do the composition, we say, oh, we got to now determine the domain of this. So therefore, we take the radicands and set it greater than or equal to 0. Add 3. 2x is greater than or equal to 3. Divide by 2, divide by 2. X has to be greater than or equal to 3/2. And then again, guys, you could do that on a number line, or hopefully you guys understand that all numbers greater than 3/2 to infinity. It would look something like that. That'd be the domain, sorry.